In this video, we're going to try to find the following limit. So our sequence an is given by n times 1 plus 1 over n quantity to the power n. Okay, here we assume that n is bigger than 1. Okay, so the idea or the problem comes from this one here. So what do we know about this one here? Okay, because we can take the limit, so this one goes to infinity. But what about this one here? Okay, if you don't know, that's not a problem, but it's also good to know this limit here. So let's assume that we don't know this limit, okay? And let's see what we can do here. The key idea is that we're going to use some algebra. Remember that algebra, and the aim of these problems is to make you strong in algebra and get you to that level of seeing what you can do, how you can find upper bounds, lower bounds, make the difference, bracket in, try to trap your sequence. So that's the key here. So what we can see is that this one here, this value, 1 plus 1 over n, for any n is less than 2. Okay, you can convince yourself. So if the only case when these two are equal is when n is 1. Okay, and that's what we have here. So other than that, so we're going to have 1 plus 1 half, okay, is less than 2. 1 plus 1 over 3 is less than 2, okay? And there are many ways, and one of the easiest way is that to see that we know how to graph 1 over x. So think of this one as 1 over x. So 1, 2, 3. 1 over x is, I'm going to graph it as a sequence. Okay, so first I'll graph 1 over x. Let's do it 1 over x. So we know that the graph of 1 over x is like this. Okay, so for me, if I'm doing it as a sequence, I care only about these points here. So notice here, so 1 plus 1 over n is this one, shifted 1 unit up. Okay, if I shift it 1 unit up, so it's gonna be something like this. Okay, so if this is 2, it's gonna be only equal to 2, only 1 n is 1. Otherwise, it's gonna be beneath 2. So this is 1 plus 1 over n. Okay, so assume that you got the idea here just by using the function and taking the sequence, the points, because the sequence is defined only for n, the set of natural numbers. So this is clear. So now I can keep multiplying this one many times to get this one times this one to get the n. So this is support to the power n is less than 2 to the power n. Now using my algebra, I can multiply here by n. So this one is less than, so this here, okay, this gives n 1 over n to the power n is less than n 2 to the power n. And this is, since this one is bigger than 1, okay, so 1, okay, 1 plus 1 over n is always bigger than 1, so it's bigger than n. So now I have my sequence, my an here. So in is between these two, between n and n to the power 2n. Okay, so so now what's the limit of this one? N, when n gets bigger, it gets bigger. So the limit of n as n goes to infinity is infinity, and therefore this limit here, it's bigger than infinity. What other value can it get besides infinity? It's only infinity. Okay, okay, this is just showing the logic. We don't need this one. Okay, since it's bigger than infinity, we don't care, but it has to be infinite. I used it here to show you that this one is also infinite. You don't have something that's finite here. Don't bracket the sequence by something that's finite. So this is infinite as well. Okay, so here this gives that my limit as n goes to infinity is just infinity. Okay, so if I can find a sequence that bounds my sequence down or lower bound and it goes to infinity, that means my sequence is going to infinity. And that's what I'm trying to do here. Okay, that means the limit here is infinity. Thank you very much.